So here we go. So during the motion of a body, if it is traveling equal distances in equal intervals of time, then such a body is said to be moving with uniform speed. Is your answer in consonance with this?
Yes.
Good.
Yes, sir.
Good. During motion of the body, if it is traveling equal distances in unequal intervals of time or unequal distances in equal intervals of time, then such a body is said to be moving with non-uniform speed. So those concepts have come here: equal distance in unequal instance of time and all. Okay, then you are done with this. So what is meant by uniform and non-uniform velocity? During motion of a body, if it is traveling with uniform speed and not changing the direction, okay, then such a body is said to be moving with uniform velocity. See, the word during motion qualifies that everything is happening in a frame of reference, okay, and you are doing the measurements in frame of reference. Alternatively, when the velocity vector associated with the body does not change during motion, then such a body is said to be moving with uniform velocity. This definition I use it because when you are representing such a motion, then you are representing this motion by simply drawing the velocity, right? And if you say this velocity vector is valid for time t between say t1 to t2 seconds, that means between t1 to t2 this velocity vector does not change, right? So it gives us a graphical representation, and you can always convert this statement into a mathematical model. That is, v bar of t is equals to, see, how will you write this statement? How will I write this statement now here? You see here. If I want to represent it, I will represent the body like this. V bar of t. Right? V bar of t is the velocity vector. Right? Now, I want to say that this body's velocity will not change between time t1 to t2. Okay? So, how will I write that? V bar of t is equal to V bar of t is equal to modulus V bar of t. See, I am introducing a new symbol here. Modulus V bar of t r cap. Okay? For t1 less than t less than t2. Now try to understand this. V bar of t represents what? What is this representing? Velocity of a body. Understood? So velocity of a body is what? What is that? Velocity of a body means? It means it is physical quantity. What is V bar of t?
Velocity.
Okay, Dhana.
It is the velocity.
It is physical variable. This thing is physical quantity. This is physical variable. See, you ಅರ್ಥ ಮಾಡ್ಕೊಡ್ರಿ ನೀವು ನೋಡ್ರಿ ಖುಷಿಲೆ ಕಲಿಬೇಕು. ಈಗ ನೋಡ್ರಿ, we are speaking some things in word, equal distance and equal intervals of time, etc. These are words. They are giving meaning, but you have to convert it into a mathematical form. So this is the point. See, this part of the statement is in words, and then you are saying that in terms of a mathematical expression. Now, further, if you want to tell that the body is moving with uniform velocity between the time t1 t2, so you write V bar of t is equal to modulus V bar of t. Modulus V bar of t means magnitude of the vector. If you write the vector between two bars, then it means you are specifying only the magnitude of the vector. Multiplied by r cap. What is r cap? It is a, hey, what is r cap? Unit vector in a particular direction, or the direction that we are under consideration. Then t1 less than t less than t2, or equal. What does this mean? That is from the time t1 till the time t2, inclusive of t1 and t2. The body is moving with uniform velocity. Understood? ಅರ್ಥ ಮಾಡ್ಕೊಡ್ರಿ. ಈಗ physics ಅಂದ್ರೆ ಏನು? Something is happening really. That reality you capture, then you put it in words, then you have to convert it into math model. Then you can use that for further analysis. So there is a way of actually representing. That is precisely what I did. Got it? Now if you want to represent it graphically, body moving with uniform velocity. How will you represent?
Velocity time.
Good. You will go for a velocity time term. Velocity versus time. Velocity versus time term. Then how will you show this?
Straight line parallel to.
We must draw a straight line parallel to the time axis.
So like this. Correct?
Yes, sir.
No. Why no? Louder. It is rest. If this is displacement versus time, it is rest. ಅದೇ ಬಯಾಟ್ ಮಾಡಿದ್ರೆ ಇದೆ ಬಯಾಟ್ ಮಾಡೋದು ಮಂಗೇರಂಗ್ ಮಾಡೋದು ನಾವು ಅಂದ್ರೆ ಇಷ್ಟ ಬರ್ತದೆ. Is this correct? Hello? Hey, louder. What is that? See, you are told time t1 to t2. This is time t is equal to 0, no? Is the velocity same at time t is equal to 0? Yes or no? You don't know. You don't know, isn't it? No. Arey yaar, see, I am trying to make sure that all of you learn very intensely. So I am asking you again and again. So you should see here. So this is not right. So the right thing will be what? V bar of t versus time. So you know the information only between these two groups. Correct? It is between t1 to t2. So what means between these two, you know the velocity is constant. Otherwise it is not. Otherwise you don't know where it is. It can be more or less or whatever it is. Understand? So you have to only show this. So this is the statement, math model, graphical model, and the geometrical. So all these three formats you should know because we are going to use this for the next stage. So you are going to learn one after the other, and these things start becoming ABCD for the entire physics. Understood? You are learning only ABCD of physics. Okay? Not XYZ. ABCD. Right. Clear?
Sir,
Huh?
I had a doubt, sir.
Huh?
You wrote here in the math model T1 means I'm not understanding what it means, sir. Means T is in between T1 and T2. Then you put the line below it. I didn't understand that. You told it.
This line. This
Yes,
line.
sir.
This means, see, this is less than. Okay, this is less
Yes,
than.
sir.
This and this means less than or equal to. Less than
Yes,
or.
but what is the meaning?
Yeah, okay.
Sir, I didn't understand what the meaning I should get from that.
Okay. Huh? See, now, supposing this is say 10 seconds to 20 seconds. 10 seconds to 20 seconds.
Yes.
So I can write this as 20 less than t less than 10 less than t less than 20. Supposing I write like this. Hello.
Yes, sir. Yes, sir.
That means this equation is valid for 10.001 per second onwards. Not exactly equal to 10th second.
Okay, I got that, sir. But when it is equal to, I can understand. How can it be equal to both?
That's what I'm trying to tell you. If I say equal to, that means it starts with the 10th second. It starts with the 10th second. See, the 10th second is also valid. If I don't write that equal to, then 10th second is not valid. Beyond the 10th second is valid. Got it? So we call it.
Yes, sir. Means, for any value of t from 10th second to the 20th second, this equation is valid.
Including the 10th and 20th second. Including the 10th and 20th second. This is valid. But if you don't write this equal to, then it is valid for all the values between 10 and 20, not including 10 and 20. Arthadala? So that is the meaning of this statement. Okay? Clear? Done. So everything is clear. Right. Nodi, idella ನೀವು cautiously ಕಲಿಬೇಕು. And these are all, when you start reading HC Verma, you are expected to know all these things. Good textbooks, you are expected to know these basic things, which they presume that you have mastered in your 8, 9, 10. You have mastered this in your 8, 9, 10. Whatever I am teaching you now is the basics necessary for you to start reading good textbooks in physics for 11th and 12th, or even including the NCERT textbook. So they expect you to know these things, understood these things, right?
Why the first one is not valid?
Hey, either this is from starting from t is equal to 0. Hey, this line is starting from t is equal to 0, no. Then how is it valid? Because I have only defined it for this set of values between t1 to t2.
But t1 can be 0.
T1 can be 0. Ignore. If I explicitly see t1 can be 0, but t1 is it equal to 0? We don't know, no. Hello, we don't know. So we have said, we have in general told t1 to t2. If I specifically say t1 is equal to 0, if I specifically say t1 is equal to 0, I should push the line this way. Otherwise, in general means it can be any value. It can even be negative value. Got it? Then, during motion of a body, if it is traveling with non-uniform speed or uniform speed but changing direction, then such a body is said to be moving with non-uniform velocity. Alternatively, when the velocity vector associated with the body does not change during motion, then does the change during motion, then such a body is said to be moving with non-uniform velocity. Got it now? Right? And when the body is having non-uniform velocity, it means it is what? It is accelerating. Understood? What is the concept? Force is a concept, speed is a mathematical concept, etc. I started with an example. Why I started this answer with an example is because I want you to understand what is a concept. It is not that you don't know what is a concept. You know something about it. So, because see, I told you. See, now, force is something, which we have said it is push and pull. But it is not always push and pull, right? A concept in science is an idea that cannot be observed. However, when a scientific concept applies to a process, okay, or an object, then it can be observed and studied. So by itself, the concept cannot be observed. Hey, I am applying force. Can you see? But supposing I have a body in front of me, and I do this, and if you see that the body is accelerating, then you say, sir, you are applying force. You got it now? So, can you see force? No, you can see the effect of force. So therefore, concept in science is an idea that cannot be observed. See, you can see a marble moving. You can see the rainbow. You can observe. But a concept by itself cannot be observed. Okay? However, when a scientific concept, see again, concepts as I told you the other day in movies also, there you see. Akri Rasta, I gave you the example. So therefore, I am making it very specific because now you say, sir, that concept I can see, no sir. A policeman, a bad policeman, a good policeman. So you can create a character, bad policeman and good policeman by appropriate concepts. So leave it apart. So in scientific concept applies to a process or an object. However, when scientific concept applies to a process or an object, then it can be observed and studied. So when I apply force on a body, if it is accelerating, then you can say it is happening. So force becomes a concept. Scientific concepts are general ideas that share characteristics. So they have certain characteristic features which can be measured. So of course the characteristics quantities that can be measured are called properties. So therefore concepts can also have certain properties. Concepts are building blocks of theories, the things being studied, compared and related to one another. A concept is an abstraction that describes a portion of the reality. A concept is an abstraction that describes a portion of the reality. Means a concept in itself may not be real, but it is a part. So supposing you want to now learn about motion, describe motion, measure motion. Force is one of the concepts that is helpful to you to understand the nature of the motion. Distance is one of the concepts that help you to understand the nature of the motion. Understand? So it is a concept, is an abstraction that describes a portion of the reality. It is a general name for a specific instances of the phenomena that is described. It is a general name for a specific instances of the phenomena that is described. Okay, anyways, these words, let it get into your head. As you start using more and more concepts, as you start developing, you will understand the meaning of these sentences better. Now let's not start a discussion on each of these terms. But I will try to give you the best of the definitions that suits your 11th and 12th standard. Right. Okay? Done. So we have answered all this. Now, theory. A supposition or a system of ideas intended to explain. Right. A system of ideas. Now, system means what? Something that is interconnected to give you a function. Right? Now, a human, you see, digestive system starts with the tongue, teeth, tongue, then your larynx, esophagus, okay, and then stomach, all the parts. So they are a system, they are well connected, and their function is to ensure that the food that you eat is digested. Okay, you call it a system. So system is interconnection parts. So here also you see a system of ideas intended to explain. That is called theory. Theory of gravity. So you are having many concepts there connected together. You are able to explain why the ball will fall down and why the moon is floating in the sky. So that theory of gravitation will explain this. So a supposition means you think that it is possible, or with this, because of this, this is happening. So you are very sure that this is why it is happening. Okay, then that becomes a theory. Especially one based on general principles independent of thing to be explained. Now this is important. Now if you build a theory for something, see, you want to explain something. So for that you will build a theory. You cannot call it as a theory. See, I want to explain something has happened. So you say, this is because of this it has happened. Oh, this is because of this it happened cannot become the theory. See, if you say this is because it has happened like this and you are able to apply that to many similar situations, then it is a theory. Develop ಮಾಡಿ ಒಂದ ಎರಡು ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ ಅದು ಥಿಯರಿ ಅನ್ನಂಗಿಲ್ಲ. See, anta similar thousands of problems you should be able to solve. Then it becomes accepted as a theory. Okay, that's it. Something or facts or events. What is that thing to be explained? A theory is well established, substantiated explanation of the aspect of natural world that can incorporate laws, hypotheses, etc. So now you see, the theory that we have all learned so far in 8, 9, 10 is based on concepts, laws, and facts.
But theory can be sometimes wrong.
No. See, this is a bad thing. And do you want to learn something or wrong? I am trying to explain what is a theory. Now you want to say theory is wrong. Why your head is going like that? See, that is what I am saying. Nin tali idragirbekalli, nin tali ಎಲ್ಲಲಾಗಿದ್ರೆ ಹೆಂಗ್ ಕಲಿತೀರಿ ಇದ? ಹಿಂಗ್ ಮಾಡಬಾರ್ದು. ನಿಮ್ದು ಫೋಕಸ್ ಒಂದ್ರಾಗ ಇಟ್ಕೋಬೇಕ. ಈಗ ಇನ್ನು ಅಂಬೆಗಾಲ ಇಟ್ಕೊಂಡು ವಾಟ್ ಇಸ್ ಥಿಯರಿ ಕಲಿಯಾಕತ್ರಿ? ಥಿಯರಿ ಕ್ಯಾನ್ ಬಿ ರಾಂಗ್. ಇದು ಏನ್ ಗೊತ್ತಾ, ವಿಡಿಯೋ ನೋಡಿ ಏನೇನಾದ್ರು ಕಲಿತೀರಿ, ಹಂಗೆ ಮಾಡಬಾರ್ದಪ್ಪ. ಈಗ ನಾ ಏನೋ ಪುಸ್ತಕ ಓದ್ಬೇಕಾದ್ರೆ ಅದ್ರ ಮೇಲೆ ಶ್ರದ್ಧೆಯಿಂದ ಕಲಿಬೇಕು ಅಷ್ಟ. ಅದೇ ಕಲ್ತ ಮೇಲೆ ದೆನ್ ದಟ್ ಇಸ್ ದ ನೆಕ್ಸ್ಟ್ ಸ್ಟೇಜ್. ಅದು ನೋಡ್ರಿ, ನೀವು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಬರ್ದಾರಲ್ಲ, ಆ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಹೈರಾರ್ಕಿದೊಳಗೆ ಹೋಗ್ರಿ. ನೀವು ನಡಕ್ಕಿಂತ ಏನೇನಾದ್ರು ಹುಚ್ಚುತ್ರಂ ಕ್ವಶನ್ ಕೇಳೋದಿಲ್ಲ. ಈಗ ಏನೋ ಒಂದು ಸೆಂಟೆನ್ಸ್ ಬರ್ದಾರ, ಆ ಸೆಂಟೆನ್ಸ್ ತಿಳಿದಿಲ್ಲ, ಅದು ಕ್ವಶನ್ ಕೇಳ್ರಿ. ನೀವು ಇನ್ನೊಂದು ಸೆಂಟೆನ್ಸ್ ಯಾವ್ದೋ ಬೇರೆ ಬುಕ್ನಾಗ ತೆಗೆದು ಅದನ್ನ ನಡಕ್ ಹಾಕಿ ಕೇಳಕ್ ಹೋಗ್ಬಾರ್ದು. ದಟ್ ಈಸ್ ನಾಟ್ ದ ವೇ ಟು ಲರ್ನ್. See, learning is, it is very sacred. You cannot, ಏನನ್ನ ಮಾಡಿದ್ರೆ ಲರ್ನಿಂಗ್ ಆಗೋದಿಲ್ಲ. ಈಗ ನಾನು ಥಿಯರಿ ಅಂತ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೀನಿ. Some theories are wrong. What should I do now? What should I tell you at answer you tell? ಈಗ ನಾನು ಹೇಳೋದಕ್ಕೂ ನೀವು ಕ್ವಶನ್ ಕೇಳೋದಕ್ಕೂ ಏನು ಸಂಬಂಧ ಅದ ಹೇಳಿ ನೋಡಿ. ಇದೇ ಹೇಳ್ತಿರೋದು. ನೀವೆಲ್ಲ ಏನಾಗಿದೆ ಗೊತ್ತಾ, ಐ ಆಮ್ ವೆರಿ ಸಾರಿ, ನೀವು ಎಜುಕೇಶನ್ ಅನ್ನ ಭಾರಿ ಚಿಲ್ಲರ್ ಮಾಡೋದಿರಿ. ಅದು ಏನೋ ಒಂದು ಸಾಲಿಗೆ ಹೋಗೋದ, ಏನೋ ಬರೆಸ್ತಾರ, ಬರೆಯುದು, ಅದಕ್ಕೆ ಹಿಂಗಾಗೈತಿ. ಸಿ ನೀವೆಲ್ಲ ಶಾಣೆ ಹುಡುಗರಿದ್ರಿ, ಯಾಕೆ ನೀವು ಮುಂದೆ ಬರೋದಿಲ್ಲ? ನೀವು ನೋಡ್ರಿ 35-40 ವರ್ಷಕ್ಕೆ ನೀವು ಸ್ಟಾರ್ಟ್ ಸ್ಟ್ರಗ್ಲಿಂಗ್ ಟು ಲಿವ್, ಸ್ಟ್ರಗ್ಲಿಂಗ್ ಟು ಗೆಟ್ ಅ ಜಾಬ್, ಸ್ಟ್ರಗ್ಲಿಂಗ್ ಟು ರಿಟೈನ್ ಯುವರ್ ಸೆಲ್ಫ್, ಬಿಕಾಸ್ ನಿಮ್ದು ಎಜುಕೇಶನ್ ಸರಿಯಾಗಿರುವುದಿಲ್ಲ. ಯಾಕೆ ಸರಿ ಆಗೋದಿಲ್ಲ ಅಂದ್ರೆ ಹೆಂಗಾರು ಓದ್ತೀರಿ, ಏನಾರು ಮಾಡ್ತೀರಿ. ಈಗ ನಾ ಏನು ಕೆಲಸ ಮಾಡ್ತೀನಿ ಅದ್ರ ಮೇಲೆ ಗಮನ ಇಡಬೇಕು. ಇದ್ರಾಗ ಏನಾರು ತಿಳಿದಿಲ್ಲ ಕೇಳಬೇಕು. ಬಟ್ ಟೀಚರ್ ಬ್ಯಾಡ ಕೇಳಬೇಡ ಅಂದ್ರೆ ಕೇಳಬಾರ್ದು. ಅದು ಬಿಟ್ಟು ಬೇರೆ ಕಡೆ ಹೊರಗೆ ಹೋಗ್ಬಾರ್ದು. ತಿಳಿದ? ಹಾಂ. So explanation of aspect of natural world that can incorporate loss theory. So that means hypothesis is there. Hypothesis means now a murder has taken place. You see a murder, and that when you see a murder, you saw one person running. Then you will hypothesize. What is your hypothesis? That person could have done the murder. That is your hypothesis, not your conclusion. And you should know, you see a murder taking place, and then supposing you see a murder and you see Sudheer Murthy running away from that scene. So what is the hypothesis? Sudheer Murthy must have committed the murder. Hypothesis. Now the proof, now investigation will carry to prove that the hypothesis is right, correct. If the hypothesis is proved to be right, then I will be arrested. Just because I ran from that scene doesn't mean that I have committed the murder. Understood, all of you? Hello, understood? Suppose
Yes,
you
sir.
say, I saw Sudheer Murthy running. Then the police will call me to the police station. Then tell, who are you? I am Sudheer Murthy. Why were you running away from the scene? Sir, I came there, sir. I saw one person was murdered. Then I thought I will be caught, so I ran away from the scene. You could only have committed the murder. No, sir, I didn't commit. Then you give your fingerprints. Take my fingerprints. What is your relation with that person? I am not related to that person. So what is your name? Which place? Who is your wife? Who is your son? All that details they will take. And they will take the details of that person. They will try to match the following. Do I have any relation? Business relation? Otherwise, no. Then fingerprints also they will match. Is there any match? No. So that means this person has not murdered. Then they'll say, sorry. Understood now? But supposing something matched. If supposing that person had borrowed 1 lakh rupee from me or some money, then maybe for the sake of money you have murdered. One theory will be built. But again that has to be proved. Understood? Conclusion. So this is hypothesis and then establishment. Science also starts like that. Okay. Now electron is revolving around the atom, now on the nucleus. So it started like that. But then there were several experiments which proved it. The theory of gravitation, for instance, explains why the apple falls from trees and astronauts float in space. So there is a theory which explains both these things simultaneously. If supposing a theory explains why apple falls down and it does not explain why the astronaut is floating, then you can't call it as a theory. You should prove the both ways. Understood? Anyways, you start using theories, you start building theories, then you will understand this. You don't have to buy out all these sentences. It is just that you should know that you cannot simply write according to this theory. You should know what that theory means. It is well established. Okay, the theory of so and so. Then you can use it. What is mass? In the classical mechanics, see, I have made it very specific. So in the first class I had shown you, there are 4 mechanics. What is classical mechanics? Quantum mechanics, relativistic mechanics, and one more. Quantum mechanics for small particles. Relativistic, those moving the speed of light. Right? Then there is one more thing, those particles are also small and they are also moving with speed of light. So it is wave theory. So there are 4 different classes of mechanics. So in all these 4, this mass is only a number, and that number has got a significance in each of the mechanics, each of the branch of the mechanics. The number becomes significant. Like for example, refractive index. So it is a figure of merit which will tell you how much the light will bend when it travels from this medium to that medium. When it travels from vacuum into that medium. That is refractive index of the absolute refractive index of the medium. So that number has a significance, which I and you have to interpret based on certain set of rules. Okay. Now similarly here, you see, mass is only a number. In the classical mechanics, what does mass mean? According to Newton's second law, we say that the body has mass m if at any instant of time it obeys the equation of motion. Equations of motion. Equations of motion are v is equal to u plus at, v bar is equal to u bar plus a bar t, s bar is equal to u bar t plus half a bar t square. Right? All those equations of mechanics if it follows. Then only it is. So, according to Newton's second law, if we say that the body has mass m, if at any instant of time it obeys the equation of motion. Correct? See the definition of mass. Yes, mass is a measure of inertia. Inertia of a body can be defined as the ability of a body to oppose the change of motion. It can also be defined as the ability of a body to maintain the state of motion unless acted upon by external forces. So, this is the complete description of what is mass in classical mechanics. And you are going to read only classical mechanics. Of course, you are going to learn quantum mechanics and also relativistic mechanics and also wave theory. So, the concept of mass will be different in different theories. And we have to apply the theory according to the situation. Okay? Just because the body is in motion, you can't apply Newton's law, as I am telling you. Newton's law is applicable to bodies which are much larger than the size of the atom and which is moving with speed considerably less than that of light. Only for these bodies you can apply Newton's law. Otherwise, you cannot apply Newton's law. Is it clear? Done. Alright. So again, we are back into this experiment here. So I hope you can read this. In general, V can be different at different institutions. Mathematically, V or P is so and so. I think we have already gone through this slide, right? And I have explained this slide in detail to all of you, right? We have explained this VA bar, etc., RAB bar, and all these things. I hope it is clear to you. Any questions here? No questions. Okay.
No, sir.
Very towards this. Because once again, I wanted to remind you this is the 6th class. That is all. Now, we will discuss more about this velocity vector. Right? So, you see this diagram, very important. Given a particle in motion along an arbitrary direction x, x cap is a unit vector along the positive x direction. I have defined what is unit vector. And then I have drawn a drawing here. You can see origin minus x plus x. I am making everything clear. Physics means representation means it should be complete and unambiguous. Right? Then you can see that I have drawn a small point and I said it is mass m and I have drawn a velocity vector. The length of the line is proportional to the magnitude of the vector, that is speed of the particle. And then I have written here Vt x cap is equal to V bar suffix x of t. These are different ways by which it can be represented. Already I have discussed this with you. Understand? V bar x of t means what? I am talking about the x component of the velocity. Okay, t, where Vt is the speed at time t, V bar x bar is the speed of the body at instant time. Okay, right? Already I have discussed this. I am just showing it more formally here. A body of mass m in the shape of a sphere and going on a smooth road without rolling along the direction present can be represented exactly like above. So it is only, if it is a particle, it will only translate. But if it is a body, it can also translate. That means it can also move in a particular direction. That means if a body is translating, that means all the particles are moving in the same state, in straight lines parallel to one another. Any translating object moving on a smooth road along the direction plus x cap can be represented exactly like that. That means, see, this ball can rotate. This ball can rotate. But if this ball is simply going like this, that means this ball consists of many particles and all the particles are going in different straight lines, but they are all moving along the straight lines parallel to one another. Then we say it is translating. Understood? See, now if it is doing like this, then we say it is rotating. And if it is doing like this and moving, then we say it is rotating and translating. So this diagram only means that the body of mass m is translating.
Translating.
That's it. That's that. That diagram implies that. Now, look at this. So here you see velocity vector is, now I am doing what here? I am applying a force vector. Force vector, the length of the line is proportional to the magnitude of the vector, that is strength of the force. Force is in the positive x direction. Right? I have applied. So as a consequence of this, what happened? If I apply force at ft of x, this one, what happens?
We have to create an acceleration.
Yes, we have to create that. We have to create an acceleration vector which is not there. So you applied force instantly. At the next instantly, what will happen here? It must be noted that in the above two vectors are along the same plane. They are collinear vectors. Note that the same unit vector is used for both the cases. You see here, x cap is used for both. Hello.
Yes, sir.
X cap is used for both. That means both the vectors are in the same direction.
Direction.
Define the unit vector at x cap.
Yes, I have already initially in the previous diagram only I defined now. X cap is a unit vector along the positive x axis I already defined, and I have already drawn the line x.
Yes, sir.
Right? I have drawn the line x and I am showing everything. That means all this is happening along the line x. The body is also on the x, on this line, and everything is happening along this, etc. So I have defined it in the first line itself, and I am using the same description again. Now I am applying force. Of course. So what is missing here? The acceleration vector is missing. Now that correction is done. So because of the force, there is instantaneous acceleration. What is the consequence if the force acts from time t1 to t2? Force acts between time t1 and t2. What will happen? What will happen?
The velocity acceleration vector is only from time t1 to t2.
Yes. Now see more specific. Correct. There is change in motion between time t1 and t2. Velocity vector changes in magnitude. A particle is accelerated. The particle will accelerate between time t1 and t2 only. The velocity vector increases during this time interval, which means speed increases. Understood? See, I am connecting various. See, artha madkodri, speed, velocity, time, motion, change of motion, state of motion, force, acceleration. See, these are all different concepts, but they are all getting interrelated like this. Sometimes some things mean the same, but you should know what it means, and you should be able to use these concepts in appropriate situations, correct and appropriate way. So if I say velocity is increasing, means what? Velocity is increasing means what? Speed is increasing.
The speed of the object is increasing.
If I say velocity is changing, means what?
Direction or the
Speed is changing.
Or the direction or the speed is changing.
Or both are changing. The velocity vector increases during time, which means speed increases. Since force vector and velocity vectors are collinear, means along the same line, during the interval of time, only speed increases but direction does not change. What is the consequence of the above pull? Andra, now this force F bar, I will say it is pushing. Why I am telling it is pushing?
Because
The direction of force.
Why am I telling that it is pushing?
the force vector is behind the object. So
The
direction of force vector is same as the direction of velocity.
That is the correct answer. The force vector is having the same direction as the velocity vector. Then only you say it is pushing. Not because it is behind. I can put the force vector ahead of velocity vector also. I can transpose it. Correct? Yesterday we have discussed it.
So like yesterday you told, we can also tell that it's the force vector is directly into the center of mass.
Now, for a particle, the center of mass itself is the particle. For a body only, the center of mass will come into picture. Understood? So why do you say it is pushing? Because the direction of the force vector and velocity vector are in the same direction. Then when you say it is pulling,
The force
vector is opposite direction of the velocity.
Velocity vector.
Understood all of you? Huh?
The force vector is in front of the object, sir, and the velocity is in same direction.
So yesterday you were absent, so this problem will, they will not have this problem. See, you can write the vector, man. See, I can show like this. This is the velocity vector. And then I will show this is the force vector. I can show like this also. Or I can show like this. This is the velocity vector. And this is the force vector. Same. Or I can show like this. This is the velocity vector. And this is the force vector. All the three are same. Vector in difference agudilla. You can transpose the vector. It is whether you pull a body or push a body. Will it make any difference? See, I am standing like this. If you push me, I will go like this. If you pull me also, I will go like this. No.
Yes,
So it is irrespective of whether I am showing the force vector behind or in front.
But that becomes full and
Adaka definition. If the velocity vector and force vector are in the same direction. See, here also it is in same direction, here also it is in same direction, here also it is in same direction. Then all of them are push. All of them are push. So you will get an impression. If you see this, you will feel that it is pulling. ಈಗ ನೀವು ರಿಫೈನ್ ಮಾಡ್ಕೋಬೇಕು. ಈಗ ನೀವು ಮ್ಯಾಥಮೆಟಿಕಲಿ ಯು ಶುಡ್ ಸ್ಟಾರ್ಟ್ ಸೀಯಿಂಗ್ ದೀಸ್ ಥಿಂಗ್ಸ್. ಈಗ ನಿಮ್ಗೇನ ಹೀಗೆ ಇವೆಲ್ಲ ಫೋರ್ಸ್ ವೆಕ್ಟರ್ ಮುಂದಿದ್ರೆ ಪುಲ್, ಫೋರ್ಸ್ ವೆಕ್ಟರ್ ಹಿಂದಿದ್ರೆ ಪುಷ್. ಹಂಗಲ್ಲ, ಅದ್ರ ಅರ್ಥ ಹಿಂದೆ ನಿಂತು ಒಂದು ದುಕ್ಷಿದ ಮುಂದೆ ನಿಂತ್ಕೊಂಡು ಹೇಳೋದಲ್ಲ, ಎಫೆಕ್ಟ್ ನೋಡ್ಬೇಕು. ಈಗ ನನಗೆ ಫಾರ್ ಮೀ ಇಫ್ ಯು ಪುಷ್ ಫ್ರಮ್ ಬಿಹೈಂಡ್, something will happen. Instead of that, if you pull from front, what will happen? Same thing will happen. No. So therefore, you should not take example like that. We are only seeing the effect. We are only seeing the effect. What is the effect? There is velocity vector, and if you apply force, then its speed increases, whether you push or pull. So for us now in physics, see, that's what I am trying to tell you. Our colloquial language and the scientific language, at some points they are different. Interpretation becomes different. You have to be careful. I am trying to pinpoint all those things. That is why I am asking you. See, why I am specifically asking this question is because you see here in your 8th standard textbook, they have described what is force, push or pull. So in 8th standard also, if I ask some student what is force, he will say push or pull. 9th also he will say push or pull. 10th also he will say push or pull. 11th also he will say push or pull. 12th also he will say push or pull. He will not understand anything else other than force. So what is told in 10th standard is sanctum. It is commandments. So I will follow. Nee bekad bere bekad kalusni. Na bare push up pull, push up pull. So ಈಗ ನಿಮ್ಮ ತಲೆಗಿಂದ ಅದ ತೆಗಿಬೇಕು. ಎಫೆಕ್ಟ್ ನೋಡ್ರಿ. And ಇಲ್ಲಿ now when you are discoursing here, you should see when I say a particle or a body, and when I am considering it in motion, the first thing you should attach is velocity vector. Did I not tell you yesterday? First attach the velocity vector. First attach the velocity vector, and then you start attaching one by one vectors. So if you attach a force vector and the direction of the force vector and velocity vector are in same direction, then you say it is push. You attach a body in motion, you attach a velocity vector, now you attach a force vector. Supposing the force vector is opposite to the direction of velocity vector, then you simply say it is pull. That is the meaning of push and pull. Got it now?
Yes, sir.
Yes, sir.
ಅರ್ಥ ಮಾಡ್ಕೊಡ್ರಿ. ಅದಕ್ಕೆ ನೋಡ್ರಿ, ಈಗ 8, 9, 10th ಒಳಗೆ ನೀವು ಏನೇನಾದ್ರು ಕಲ್ತಿರ್ತಿರಲ್ಲ, that is the problem. So your mind is stuck with that. Understood? Now, did you understand what I told?
Full example can you give it that?
Full example. Good. So, can you imagine your friend going on a cycle in front of you? Can you imagine? What are you imagining?
Friend going on a cycle.
Friend is going in cycle in this direction. Now, you hold the carrier of the cycle and you start pulling it. So what happens? Your friend is going. So you will hold the carrier. Your friend is going like this in cycle with some velocity. You will hold the carrier and tell, Hey, Nindralepa, stop. You are pulling. What will happen?
Its speed gradually
Loud.
speed gradually
Its speed is decreasing. So you are pulling. You continue to pull. Then what happens?
its speed slowly comes to zero.
Then also you pull.
Yeah, in the opposite direction.
You start moving in. So you are continuously pulling only, no? You are applying force like that. You are telling it is company. You are always pulling. But now your speed starts increasing. When you are doing like this, also speed decreased. When you are doing like this, speed also increased. Then are you pulling or pushing? Hey, Dana. Come on, this experiment you understand. You tell. Your friend is going like this. You hold the carrier and start moving your hands towards your shoulders. What happens to the cycle? Its speed goes on decreasing and then comes to rest. And then what happens?
Again, it starts to increase in the direction of force.
In the direction of your shoulder, correct? No. So before the cycle's velocity came to zero, were you pulling or pushing?
When it comes to zero, I was pulling.
Hey, Dana, before it came to zero, whether we are pushing or pulling?
Pulling.
You are pulling. Then after it came to zero, were you pulling or pushing?
I was pulling.
Did you understand the situation? The cycle is going with some velocity. You were doing like this. So are you pulling or pushing?
Till it comes to zero, I was pulling.
Till it comes to zero, I am pulling. And after it comes to zero?
Like in local language, we will call
Hey, Dana, ida language na khelale. Till it came to zero, you said it is pulling. After it comes to zero, what are you doing?
Then we are pushing.
Then you are pushing. Wait a minute. Then you are pushing. Are you understood? Correct? Correct, no?
Yes.
This is exactly what it is. Idana nana scientific term la correct. First time na neenu pulling anta yakandi because the velocity vector was like that and the force vector was like this. Then second time you said you are pushing. Why? The velocity vector was like this and the force vector was like this. Understood now? So you are now converting that 8th standard statement into scientific term. So what push
But
and
when the cycle was at when the speed was zero, should we call it as push or pull? So when it was at zero.
So that is a boundary condition. That's a boundary condition. Hello, that's a boundary condition. Now
Yes.
Listen here. How to answer that question? When the velocity of the cycle becomes zero, what is the vector? What is the velocity vector? You call it as null vector. And
Null vector.
how did I define null vector?
Means its magnitude is zero, but it has some direction, but we don't know the direction.
You cannot specify the direction. So therefore now at that juncture, whether the velocity vector is in the direction of the force vector or whether it is opposite to the direction of force vector, you don't know. So at that particular moment, you are neither pushing nor pulling. You are neither pushing nor pulling because you don't know what is the direction of the velocity vector. If you know the direction of the velocity vector is like this and the force vector is like this, then you call it as push. If you know that the velocity vector is like this, the force vector is like this, then you call it as pull. But you don't know what is the direction of the velocity vector. But yes, you know the direction of the force vector. But you cannot say whether it is push or pull. So at that moment, you cannot say whether it is push or pull. Is that clear? So that is how you have to.
If they ask a question, what should we write?
You should say. See, what is the question they will ask you? You ask the question. I will tell the answer.
Means when the speed of an object is zero, and there is a force vector acting on the object, what is the force? Is it push or pull?
It is neither push nor pull. The answer is it is neither push nor pull, or you can say we can neither say it is push or pull. Understood? It is you can neither say it is push nor pull because for push means both vectors must be in the same direction. For pull means both vectors must be in opposite direction. Now these two conditions are not satisfied, then I don't know whether it is push or pull. I can use the word push and pull only if I know these two vectors are in the same direction or in opposite direction. But if I don't know that, then I don't know. That's it. See, science is like this. It is defined for this. If this condition is there, this is there. If that is not there, I don't know. The answer is as simple as that. See, you will only speak the truth. If you don't know the truth, say I don't know. It neither comes under the definition of push nor it comes under the definition of pull. Then I don't know. It can be something else. So you create a concept and tell. Understood all of you?
Okay, sir.
That's it. That's it. Okay, done. Okay, shall I proceed?
Yes, sir.
But one thing is for sure. Either it is push or pull. What is the direction of the acceleration? Your friend's cycle is going. You are doing like this.
In the direction of
You are doing like this. Then the velocity vector was like this. It slowly becomes 0. And then the velocity vector becomes ulta. So as long as your hand is moving towards your shoulder, what is happening? You are applying force. What is the
Yes, sir.
direction? What is the direction of the acceleration?
the
The
direction
direction
of
of
It's always in the direction of force.
Yes.
It is always in the direction of force. Got it now?
Yes, sir.
Irrespective of the velocity. So velocity vector is independent, acceleration vector is independent. If both of them are in the same direction, then speed will increase. If the acceleration vector is opposite to the direction of velocity vector, then the speed will decrease. I will discuss that more. Understood
Yes,
now?
sir.
Good. So what is the consequence of the above pull? What is the consequence of the above pull? What happens here?
The object of mass will start to decelerate, then it will come to rest and will move along the force vector.
We'll move along the
Force vector.
first two correct ಹೇಳಿದ್ವಿ ಆಮೇಲೆ ಅಲರ್ಟ್ ಮಾಡಿದ್ವಿ. If you pull
It
what
will move
happens?
along the velocity vector which is caused due to the force vector.
ಅರೆ ಯಾರ್ ಕರೆಕ್ಟ್ ಹೇಳಕತ್ತಿದ್ದಿ ಯಾಕೆ ಅಲರ್ಟ್ ಮಾಡ್ಕೊಂಡಿ? What is the consequence of the pull? The velocity keeps on decreasing, it becomes 0 and starts accelerating in the direction of the force vector. And the speed goes on decreasing, it becomes 0, and after it becomes 0, if the force still continues, then the speed will increase in the negative x direction.
So
That
but
is-
here,
Yes.
like the force vector is in the same direction of velocity vector.
In this case, ಯಾರ್ ಇದು ಮುಗಿತದೆ ಇಲ್ಲಿ ನೋಡಿ ಹೊಸ ಕ್ವಶನ್ ಕೇಳಿನಿ. ಈ ಹೊಸ ಕ್ವಶನ್ ಈಗಿಲ್ಲೇ ವಾಟ್ ಇಸ್ ದ ಕಾನ್ಸಿಕ್ವೆನ್ಸ್ ಆಫ್ ದಿ ಅಬೋವ್ ಪುಲ್? See, this is push. So if you pull, that means your force vector will be ulta. This is for push. If you pull, you will have to show the diagram with the force vector in the opposite direction. Got it now? ಸೊ ಇಷ್ಟು ಸೆನ್ಸಿಟಿವ್ ಆಗ್ಬೇಕು.
Yes, sir.
ಈಗ ನಿಮ್ಮ ತಲೆಯಾಗ ಬರೇ ಸೈನ್ಸ್ ಇತ್ತು, ಇದೆಲ್ಲ ಬರ್ತದ. ಈಗ ಏನು ಬರ್ತದೋ ದೇವ್ರಿಗೆ ಗೊತ್ತು. Now see what happens in the above situation. What happens at t if the direction of force reverses? Same thing what we discussed. Here two vectors are collinear. In both cases, velocity vectors undergoes change. First thing is force vector is acting, velocity vector will undergo change. Point number 1. ಯಾಕಂದ್ರೆ ನಿಮ್ಗೆ ಇದೆಲ್ಲ ಯಾಕೆ ಕೊಡಕತ್ತೇನೆ ಅಂದ್ರೆ these are questions asked in NEET and mains exam and also in your board exam. One thing is sure, if force is acting, whether it is push or pull, velocity vector will change. That is for sure. Understood now? So your hierarchy of answering should be like this. What you are more sure, you write the first sentence. Okay? Science is all about reporting the truth, the maximum truth. Then see the next sentence. In this situation, acceleration is always in the direction of force. Okay? Second, because we are very sure, I am writing these statements. See, you should develop this knack of writing the truth. If now you see, if v modulus v bar t greater than 0, speed will decrease and the direction will not change. That means v bar t in this case is greater than 0. That means what does this mean?
The magnitude of the velocity is greater than 0.
Hey, adu ನೋಡಿ ಇಂಗ್ಲಿಷ್ ನಾಗ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡಂತ ಹೇಳಿಲ್ಲ. What is the meaning of that? modulus v bar t greater than 0, speed will decrease, direction will not change. What is the meaning of this?
So the body will decelerate.
The body is not at rest.
ನೋಡು ಅವ ಮಹಾ ಉಡಾಳ ನಿನ್ನೇನು 8 ಗಂಟೆಯಿಂದ 3 ಗಂಟೆ ಮಟ್ಟ ಬಂದಾನ ನಾವು ಎಲ್ಲ ಮಾಡ್ತಾನ ಅವ್ ನೋಡಿ ಹೆಂಗೆ ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಕತ್ತಾನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ರಿ ಈಗ ನೋಡಿ ಅವ್ನು ಕುಡ್ಸೇನ್ ಇಲ್ಲಿ ಯಾಕೆ ಸಿ ಈಸ್ ಜೂನಿಯರ್ ಟು ಯು 2 years ಜೂನಿಯರ್ ಟು ಯು ಅಂಡ್ ಅರ್ಧಂಬರ್ಧ ಅವು ಅವಾಗ ಏನಾದ್ರು ಒಂದಿಷ್ಟು ಬರೀ 8th ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಟ್ಯೂಷನ್ ಬರ್ತಿದ್ದಾವ ಅವಾಗ 8th ಸ್ಟ್ಯಾಂಡರ್ಡ್ನಾಗ ಅವ್ರಿಗೇನು ಇದೆಲ್ಲ ಇಲ್ಲ ಅವಾಗ ಏನಾದ್ರು ಒಂದು ಹೇಳ್ತಿದ್ದೆ ಅದಂತರ ಅಷ್ಟದಾಗ ಅಬ್ಸ್ಟ್ರಾಕ್ಷನ್ ಬಂದೈತಿ ಈಗ ಅದು ಉಡಾಳದ ನಾವು ಪೂರಾ ಅವನು ಅಭ್ಯಾಸ ಮಾಡಿದ್ರೆ ಮುಂದೆ ಬರ್ತಾನ ಬರಂಗಿಲ್ಲ ಅವ್ನು ಯಾಕಂದ್ರೆ ಆರ್ಯನು ಸೊ ದಿಸ್ ಮೀನ್ಸ್ ವೆನ್ ಯು ಅಪ್ಲೈಡ್ ದಿಸ್ ಫೋರ್ಸ್ the speed was there, the body had some speed, it was greater than 0 in that direction. Okay, at t, if see I applied force at t, that the body was still moving, right? And therefore what happens at t the speed starts decreasing. Now if v modulus v bar t is equal to 0, that means the body is at rest, direction will reverse, speed will still be 0. Further, if force continues, that means at that instant, you understand here, if the body is at rest, you apply force at that instant. Exactly at that instant, immediately the velocity will not change. I think I have discussed this yesterday. So, the velocity is still 0. And if the force continues beyond t, then the speed increases negative x direction. I hope it is clear. Now, if
so you told the direction will reverse and speed will still be 0. But the direction will reverse when the force continues to act, no sir?
ಈಗ ಇಲ್ಲಿ ಏನು ಬರ್ದೇನಪ್ಪ at the time t, if the body was at
Yes, sir.
rest, at the time t, if the body was at rest, okay, at time t, if the body was at rest, the direction will reverse. See, here you see the cycle was going like this, momentarily it stopped.
Yes.
But the force was like this. That is the condition here. Then it will still be 0. That is, at the instant if you apply force, instantly it will not change. Further, if you further continue to apply force, then the speed will increase in minus x direction. Got it?
Yes,
Then,
yes sir.
now see, if at time t, modulus v bar of t is less than 0, it cannot happen. Speed cannot be negative. So, you ಬರ್ಕೊಂಡು ಹೋಗ್ತೀವಿ t v of t greater than 0, v of t equal to 0, v of t less than 0 ಅಂದ್ಕೊಳ್ಳೆ ಇನ್ನೇನ ಬರೀ ಹಾಕೋಬಾರ್ದು. Immediately you should stop and say, sir, this condition is not possible. Then what happened to the body? Arya, this condition is not only not there. Speed cannot be negative. Understood now? This is how, see, this is a direct question. This is a question asked in your competitive exams, later in board exams, etc. etc. So they will ask questions like this. So you see, what you would have written if you had got this question in exam? They would have given you this vector and said what happens. So if you have deeply understood the meaning of this and connected it to the reality, then you would have understood this. I told cycle example. Can you give me any other example where I can show this whole thing? That is, this is also there and this is also there. Can you give me an example? I gave cycle example. Any other example where I can show this? Sorry. Any other example?
So while an accelerator.
Germany book, go. Right. Now all of you can see this. See, this one is spring loaded. Okay, and I am just keeping one ball. Right. So what do? I will push this. So now you see the spring is compressed. The spring is compressed. So I have done work. This work is stored in the form of potential energy. Okay. Now I am going to release this. Right. So what happened? Now you have to explain this. Once again, give me this. I am going to release this. Don't worry, dumb anangilla. Okay, right. 1, 2, 3. I am going to release this. So you saw the ball went up and came down. Of course, this is not perfectly vertical, that is why it went in a parabolic shape. If I had kept it perfectly vertical, then it would have gone up straight and come down straight. Understood? So if it was, see, this should be kept vertically vertical. Then, you saw this? See, vertically went up and came. Now, can you relate it to those diagrams that I said? So, now what happened? When I pressed it here, and I left my hand. So, I am leaving it in slow motion. Then, the ball is in contact with this. So, force is being applied. Now, force starts being applied. So, at that point, it had some velocity. So, it started its journey from here with certain velocity. So, when the velocity vector was in upward direction, but gravitational force vector was in the downward direction. So what happened to this ball? This ball, speed went on decreasing. It reached a maximum position, 0, but the force was still down. So its speed started increasing in the negative direction. Isn't it a good example? Force is always acting down. Initially the velocity was like this, and then it becomes 0, and then this. This is the simplest example. If you throw a ball vertically up, whatever I have told comes. Because I was showing the forces like this, you are only imagining car is going there, truck is going there, it goes into dicky. See, you understand, See, that is what I am trying to tell. This is that childish thinking. So if I show vectors like this, means everything is moving horizontal. Understand? See, what I have shown that you can put it in any direction. Even for vertical, you can use the same direction, same diagram. Understood all of you? So those two diagrams, I can use it for this. Got it? The ball up, this was the diagram. Velocity vector is up, force vector is down. And once it reaches the highest position, then this was the diagram. Because the force vector is down, velocity vector is also down. Got it now? Only thing is the order has changed. Understood now? So these are all general diagrams, general ways of representing motion. So horizontal doesn't mean it is horizontal. Okay, na? Okay. Now you should think about examples which are simple. Don't complicate it. Don't irritate the examiner. And you have to use simple things and make the concepts and whatever you understood easy. Okay? I suppose you got this. Okay. So we have discussed this. Right? So this possibility is only not there. That is the answer that you have got to write. Okay? Right. Now, next one. What is the consequence if the force acts from time t1 to t2? Right? So here see, there is change of motion between t1 and t2. The particle accelerates between t1 to t2 only. Since the acceleration vector and velocity vectors are collinear during this interval, only speed changes, but the motion will be confined only to the x-axis for further. Depending upon the magnitude of the velocity and acceleration due to time t1 t2, okay, one of the following is possible. Vt2 is greater than Vt1. Are you understanding? What is this? You tell me.
Speed at time, velocity at
The
time.
magnitude of velocity at time t2 is less than the magnitude of velocity at time t1.
ಅದು ನೋಡಿ ಇಂಗ್ಲಿಷ್ ನಾಗ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡೋದು ತಿಳಿಲ್ಲ ರಿಯಾಲಿಟಿ ಹೇಳ
The speed reduced, but the direction didn't change.
Speed reduced,
But the direction didn't change.
did not change. So you see,
The force was acting in the opposite direction.
correct. So as a consequence of this, if I show you this diagram, and if I say the force is going to act between time t1 to t2, then what are the consequences? One consequence is the velocity, the speed at time. One thing is only speed will change. The speed at later time t2 will be less than speed at later time t2. See, this particle was going at 10 meters per second. You started applying force at time t1. Okay, and after 1 second, its speed is now 5 meters per second, but in the same direction. So modulus Vt2 is less than modulus Vt1. This is one possibility. Hello.
Yes.
What is the second possibility? Modulus at Vt2 is 0. You at the object at time t2 becomes 0 because you are applying force. The speed went on decreasing, and ultimately it becomes 0 at time t2. This is another possibility. Third possibility, Vt2 is equal to Vt1. When is this possible?
When there is no force acting on the object.
Allah.
So when like
The force keeps on.
the object is moving in opposite direction.
So now you see this ball. You see this ball, all of you. So this ball went up. At this point, it had some speed. Velocity was in this direction, but it had some speed. The ball went up and again came back. At this point, its velocity was this, but speed was something. Now, soon you will prove that the speed at this point is same. Velocity while it is going up is like this. Velocity while it is coming up like this. But the speed is same. Till then, ಈಗ ನಾವು horizontal ಆಗಿ explain ಮಾಡಬೇಕಿದ್ರೆ ಬೇಡ ಬೇಕಿದ್ರೆ ಹೇಳ ಈಗ ನಿಮ್ಮ ಖಾಸ ಸೈಕಲ್ ಆಗಿ ಹಿಂಗೆ ಹೊಂಟಾಳ ನೀ ಜಗ್ಗಿದಿ. So ಜಗ್ಕೊಂತಿದ್ದಾಗ ಏನಾಯ್ತು, her speed was 10 meters per second. As you jug, that speed goes on becoming 5 meters per second, 2 meters per second, 1 meter per second, 0. And you continue to jug, then the speed starts increasing in this direction, 1 meter per second, 2 meters per second. At this point again, the speed is 5 meters per second. So Vt2 is equal to Vt1. Modulus Vt2 is equal to modulus Vt1. Got it now?
Yes, sir.
Now, can I write V bar T2 is equal to V bar T1?
No,
It is not possible. When is it possible?
when no force is
When no force is acting. Got it now? Speeds can become equal, but velocities cannot become equal at T2 because force is continuously acting. Understood?
Yes, sir.
Then
Yes, sir.
the next possibility. Modulus Vt2 is greater than modulus Vt1. So you go on applying force 5 meters per second, 6 meters per second. Understand? So the speed is now increased but in the reverse direction. Artha adala? So idella nimage exam na ಕೊಡ್ತಾರ. ಇದು diagram ಕೊಟ್ಟ A B C D, this is possible, this is possible, this is possible, this is possible. Which are possibilities? So they will give you option A, B, C, D. These are the possibilities they will give you. So you choose multiple choice question. A is correct, B is correct, C is correct, or D is correct. Which is correct? Understood now? Now an intelligent examiner, he will say, he will remove this modulus sign. And then he will say A is correct, B is correct, C is correct, D is correct.
A, B and D.
ಅರ್ಥ ಆತಲ್ಲ? ಇದನ್ನ ನಾನು ಕಲ್ಸೇನಿ ನಿಮ್ಗೆ ಹೇಳಿನಿ. ಈ ತರ ನಿಮ್ಗೆ ಇಂಟೆಲಿಜೆಂಟ್ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ. ನಿಮ್ಮ ಕಾನ್ಸೆಪ್ಚುಯಲ್ ಕ್ಲಾರಿಟಿ ಇತ್ತು, ವೆಲಾಸಿಟಿ ಅಂದ್ರೇನು, ಫೋರ್ಸ್ ಅಂದ್ರೇನು, ಆಕ್ಸಲರೇಷನ್ ಅಂದ್ರೇನು, ಯಾವಾಗ ಏನೇನಾಗ್ತೈತಿ, ಮೆಕ್ಯಾನಿಸಮ್. See here it is not only the concept but the mechanism involved. See the mechanism involved. The force vector and the velocity vector are collinear, acting on the body simultaneously. Mechanism. That also should be understood. Then only you will be able to make up this. Got it?
Yes, sir.
Right. You have told your parents to come and pick you.